Hey everyone, welcome to Code Harmony. Today we are going to solve LeetCode problem ID 2594, minimum time to repair cars. This problem is based on binary search and answer space. Let's have a look on the problem statement. Here we are given an teaser array ranks representing the ranks of some mechanics. Rank I is the rank of ith mechanic, and a mechanic with rank R can repair n cars in R into n square time minutes. So this is the equation that we are going to use. Apart from that, they are saying that you are also given an teaser cars representing the total number of cars waiting in the garage to be repaired. What we have to return is minimum number of time taken to repair all the cars. Okay, so what is our given input is one array rank, and the rank is the rank of each mechanic. So here we can say in this example we are having 4 mechanic in this garage, and the rank of all mechanics are 4, 2, 3, 1. The rank means the first mechanic is going to take a time equal to rank into n square to repair n number of cars. So this is the equation that is given to us, and these are the total number of cars that we have to repair, and at the end we have to return the minimum number of time taken to repair all the cars. These are the constraints. The rank dot length is 10 to the power 5, and every rank value is going till 100. So if the rank is 100 and n is the number of cars, 10 to the power 6, 10 to the power 6 into 10 to the power 6 into r. This time might go into the long. So I hope the given part is clear to us, that rank is given to us in the form of array, and total number of cars is also given. And what is the operation? Operation is something that any mechanic is going to repair n number of cars in r into n square time, where r is the rank of that mechanic. And what we have to return in the end is minimum time taken to repair all the cars. And mechanics can work simultaneously. All the mechanics can work in parallel on different cars. Let's build our approach and see how we can do to solve this problem efficiently. Here we require minimum time to repair all the cars. Let's firstly forget about the minimum constraints, and let's say what time we can take to repair all the cars. If let's say I am assigning all the cars to the first mechanic, then how much time that the first mechanic is going to take? That is going to take r into n square time. Here the r value is 4, n value is 10, the square is 2. The total time taken by the first mechanic is 400. So 400 is the time. It means at least 400 time we can take to finish all the cars, to repair all the cars. But here we have to keep the minimum time. Here to reduce the load, reduce the time, we have to distribute cars properly to all of these mechanics. Let's say here we are distributing in such a way that we are assigning 3 cars to every mechanic. If I assign 3 cars to first mechanic is going to take 4 into 3 square time. 4 into 3 square time. Second mechanic is going to take 2 into 3 square time. Third mechanic is going to take 3 into 3 square time, and the remaining 1 car, 9, and 1 car is going to be repaired by the last mechanic. In that case, what time we are going to take? 36, 18, 27 plus 1, 27 plus 55 is equal to around 82. I might be wrong, but yeah, this is significantly less than this time. So here we have reduced the time by distributing the values. But I can't directly say like how I'm going to distribute the values. But I'm damn sure that if we are distributing evenly, the time is going to be reduced definitely. Here what I did so far is, if I just take the mechanic with the maximum value and assign all the cars to that mechanic, we are going to take the maximum time, 4 into 10 to the power 2. This is the maximum time. Our time won't go beyond this. But if we try to distribute the load evenly, we can reduce our time step by step. And let's say if we are having enough ranks, let's say we are having 5 person, and with the rank value maybe let's say 1, and we are having 5 cars, then we can give 1 car to every mechanic, and our time will be reduced to 1 minute. as far as we distribute the cars, we keep on reducing the time. So our time frame will always be in this range. Here, why I am focusing on time? Because we don't see any criteria to distribute the cars over these 4 mechanics, right? Because we have we don't have the way to decide that whether the distribution is correct or not, and if that is not correct, how to correct it. So if we just focus on the time, my time will definitely go within this range. If on this range, this time will definitely be sorted it will be sorted in the increasing order. If I just pick the middle time, let's say the middle time is 70 minutes. 70 minutes. Can I check whether I will be able to do the job in 70 minutes or not? How do I check it? Every mechanic is using this formula. R into n square is the time taken by the mechanic. And let's say the time I have already fixed. Time I have fixed to 70. So in the 70 minutes, how many car a mechanic can fix? 70 divided by R, and then it is equal to n square. So if I just take the square root of this, number of cars is equal to 70 divided by R square root. So this is the formula. This is the formula to figure out how many cars a mechanic can pick in this time frame. Within 70 minutes, how many car any mechanic can fix? How many car 4 mechanic with rank 4 can fix, rank 2, rank 3, rank 1. And in the problem statement, it is given that all the mechanic can work simultaneously. So we are going to assign load to every single mechanic. Can we skip this mechanic and assign load to all the others? No, because it won't be the optimal way. We have to use all the mechanics and assign load to all the mechanics in such a way that figure out how many cars that mechanic is going to fix within this time. So in short, I'm getting an idea that if I just maintain a range, let's say this is left and this value is right, and then I'm figuring out the mid. In that case, this 70 is mid. How many cars this mid time is going to fix? So in the time middle value divided by rank of each mechanic, taking the square root, this is the number of cars every mechanic is going to fix. First one is going to fix 70 divided by 4. Second one is going to fix 70 divided by 2. So here, if I just try to do the dry run, first mechanic is going to take 70 divided by 4 and taking the square root. 70 divided by 2 taking the square root. 70 divided by 3 taking the square root, because time is fixed but rank is different. And this value is going to give me number of cars we can fix. If I just take the sum of all the cars, we will get to know that whether how many cars we can fix within 70 minutes. If that number of car, let's say that is count, if that count is greater than equal to cars, it means we can fix all the cars, right? If we can fix all the cars, then we will try to reduce the range. See, listen carefully. If I say that I can fix all the cars within 70 minutes, it means I can fix all the cars more than 70 minutes. So this space is not required, because in this space we are definitely going to increase the time. We're not going to get the benefit out of it. So we have to go left. So our range will something look like this. That this is the range, and on this range, these are the times. And on this times, we will decide whether I can fix all the cars number of cars or not. Let's say at this moment I'm able to fix it. So after that I will be able to fix it, and left side of that I won't be able to fix it. So the array will look like this: 0 0 0 0 1 1 1 1 1 1 1, like this. our state will look like this: can fix or can repair, and the can repair function is going to take middle, and middle is our time, expected time. And can I repair all the cars in that expected time? Yes or no? So this is no and this is yes. Left side is no, right side is yes. And from this yes no array, binary array, what I have to find out is finding the first occurrence of 1. Finding the first occurrence of 1, because that is going to be my answer. First position of 1. First position where this condition is true, right? So here what I am going to do is I'm going to apply the standard vanilla binary search template on times, different times, and the time value will go from starting from 1 and going till mechanic with the highest rank and taking up all the cars. That is the maximum time I can take. So here if I try to write the pseudo code, first of all we have to do the initialization. Value of left will be 1 and the value of right will be, can the value of left can be 0? It means 0 time, no, like at least 1 minute we have to require. Right is maximum rank into cars scare. So this is the max, this is the range, and in this range I can figure, I can initialize L with 1, no big deal. But here R is equal to maximum of rank into car scare. Cars is already given, and to figure out maximum of rank we need to process an iteration. We will be doing an iteration to figure out that value. Okay, after that what I have to do is while left is less than equal to right, I am going to capture the mid. Mid is equal to left plus right divided by 2, or the other way around, left plus right minus left divided by 2. After that I will check one condition: can repair all the cars in mid time. These are the cars and these are the ranks of every mechanic. Can I repair this? If I can repair it, I will just capture my answer, and this mid is my answer. If I have captured my answer from this range, it means I can repair all the cars within this. Then I will try to explore further on exploring on the left side. So right is equal to mid minus 1. What is the else part? If I can't repair all the cars in mid time, then increase the time. Left equal to mid plus 1. So this is my pseudo code for the binary search, and this answer is going to capture the answer in the end. And here we have to have a look on this helper function. Can repair is something we have to implement, otherwise it is just a vanilla binary search. And how do I implement the can repair? For the can repair, I know the array 4 2 3 1. Let's say the array is 4 2 3 1, and the middle is something time. Middle is the time I'm expecting, and I have to fix all the cars. I will try to see in this mid time how many cars I can fix. This is the rank. Time is mid divided by rank and taking the square root, and summation on every single element I equal to 0 to n minus 1. So this value is my count, and count should be greater than equal to cars. If that is the case, return true, otherwise return false. So this will be my helper function, and this helper function is going to take order of n time. Order of n time on this value. If I just have a look on the constraints again, rank value is going till 100 and rank dot length is going till 10 to the power 5. So till 10 to the power 5 is the time order of n for finding the maximum value, and order of n to find the count. After that, on our range, let's say time value, this is the maximum time value, this is the maximum time value, and let's say the maximum time value is t. So our overall time complexity will be order of log of t to figure out the time, and let's say n is the time to check the condition. So this is the time complexity. And what about the space complexity? Are we using any extra space? No. Space is constant. We don't require any extra space apart from couple of variables. So this is the code. This is the code that I have to implement. Let's write the code now. Here first of all I have to define the range. L is equal to 1, and here in this case R is going to be the maximum value I need to capture. Let's say I'm just capturing the maximum in the R. To capture the maximum, int rank, that is ranks. R is equal to math dot maximum R comma rank. So now R is having the maximum rank, and that maximum rank should be multiplied with the cars square. So R into cars into cars. So this is the maximum range I can have from L equal to 1 to R. Now I just have to apply the binary search algorithm. While left is less than equal to R, first of all capture the middle element. One thing we have to keep in mind that this variable should be long, because here this R can go out of range from integer range. L is less than equal to R, also the long will be the middle. Here the middle will also be the long, and middle is equal to left plus right minus left divided by 2. Now if can repair middle I am passing, ranks I am passing, cars I am passing. If this is the case, just capture it. Otherwise capture and explore on the left side. Right is equal to mid minus 1. Let me take the answer variable as well. Let's initialize the answer with n. Okay, this I have initialized. Else part, if I am not able to fix or repair all the cars in mid time, then I will go right side. To go to right side, RL left is equal to mid plus 1. So now this is the binary search I have written, and in the end I'm going to return my answer. Now we just have to implement this helper function. Let's implement that as well. Private, this is going to return boolean can, and long, this is the middle, this is the integer array. Here I need to see how many cars I can repair within this time using these mechanics. So for that I am taking a counter int, let's say count is equal to 0. For every rank I need to append my counter plus equal to math dot square root. This formula we have discussed in the discussion, mid divided by rank. So this formula is going to give me the number of cars I'm going to repair. And if at any moment this count is greater than equal to cars, then return true. Yes, we can repair all the cars. Otherwise return false. Yeah, this is the code. This is the range we have decided, and after that on this range I have applied the vanilla binary search template, and this is the condition to validate whether this mid value is valid or not. Let me run over sample test cases. Sample test cases are passed. I'm submitting the problem. Got submitted successfully. I hope you understood the approach. In case you get any doubt, you can discuss in the comment section below. Thank you guys. Bye bye.